We introduced the unit circle in the last video, and now we're going to see it as one big diagram. So as I mentioned before, what the unit circle allows us to do is it allows us to take all those little visuals we've been doing for 30, 45, 60, 0, 90, 180, 270, like they were all separate little visuals, and it's going to allow us to just put it into one big visual. So that's what the unit circle allows us to do. Now I make a little note, you do not need to memorize this because it's information that's already should be known, just being placed in a different diagram. Of course, you can memorize it, but what's the more important part is that you understand how it's put together. That's really the key, especially as we move forward. So as a quick reminder, the unit circle means that the radius is 1. And so the cosine of theta will be the x. So when you have x comma y, the first coordinate is the cosine and the second coordinate is the sine. Because normally it's x over r and y over r, but if r is 1, then you don't need to write the over 1. So let's begin by talking about our axis angles, like placing our angles that we know for sure. So this is going to be 0 degrees, also known as 360. In radians, that's 0 and 2 pi. At the top is 90 degrees, or pi over 2. On the side is 180, or pi. And at the bottom is 270, or 3 pi over 2. And then we have our 3 other golden angles, 30, 45, 60. So the first one is 30, a third of the way in. In radians, it's pi over 6. The next one is 45, pi over 4. And the next one is 60, pi over 3. So let's begin with our axis angles. Now, the points on the unit circle for our axis angles are exactly the same points we were using for our visual because the radius is 1. So for 0 degrees, it's 1, 0. For 90 degrees, it's 0, 1. For 180 degrees, it's negative 1, 0. And for 270 degrees, it's 0, negative 1. One of the things I do notice is that sometimes people mix up their x and their y's. Like at 0 degrees, they write 0, 1. Be active about it. Think about it. Did I move my x? Did I move my y? Just double check that. Okay, and in the previous video, we did the 30, 45, and 60s by making the hypotenuse 1, and then we placed the triangles in the unit circle. So for 30 degrees, that was radical 3 over 2, 1 half. 45 degrees is radical 2 over 2, radical 2 over 2. And 60 degrees is 1 half, radical 3 over 2. So again, cosine is the x, sine is the y. So the cosine of 60 is 1 half. The sine of 60 is radical 3 over 2, which we already knew when we drew our little triangles. So next what we're going to do, and the key of the rest of the unit circle are reference angles. So because we have 3 angles in quadrant 1, 30, 45, and 60, we're going to create those angles in every single other quadrant. So that's going to be the reference angle in quadrant 2, in quadrant 3, and in quadrant 4. So in quadrant 2, the reference angles goes from the negative x-axis, so from 180. So the first reference angle of 30 will be the first point. And then we'll have a reference angle of, 45. That will be the second. And last but not least, the biggest one will be a reference angle of 60 degrees. So if we're going from 180 minus 30, because we're subtracting, we're going closer to 90, is going to be 150. 180 minus 45 is 135. And 180 minus 60 is 120. And then to do the radians, use the reference angle. So the first one, I'm using 30 degrees. So 5 times 30 gives me 150. 30 degrees is pi over 6, so this is 5 pi over 6. 135 is 3 times 45 degrees. So this is going to be 3 pi over 4. And 120 is 2 times 60 degrees. So this is going to be 2 pi over 3. So again, you don't have to memorize, just think about which reference angle you're using. The next part is going to be the reference angle theorem. So we begin by looking at 150 degrees. 150 degrees has a reference angle of 30, which means that it's going to be associated to the exact same point as 30 degrees, which is this point. The only difference is that the signs could be different. And in quadrant 2, x is negative and y is positive. So instead, the point will be a negative radical 3 over 2, comma, a positive 1/2. The next one has a reference angle of 45 degrees. Oops, I meant to highlight that. So 45 degrees, so it's going to have the same point as 45 degrees, but the x will be negative. So it's going to be a negative radical 2 over 2 over radical 2 over 2. Everything is dependent on the reference angle. And last but not least, the reference angle of 60. Oh, I did it again. Highlight, not right. Here's 60, here's the point, but the x will be negative. So I have a negative 1/2, a positive radical 3 over 2. So if I wanted to know the sign of 135 degrees, then I look at the y coordinate. It's a positive radical 2 over 2. So the sign of 135 is radical 2 over 2, a positive because it's in quadrant 2. Let's do it for quadrant 3. So the first one is going to have a reference angle of 30. The second will have a reference angle of 45. And the last will have a reference angle of 60. So now I'm adding from 180. So 180 plus 30 is 210 degrees. 180 plus 45 is 225. And 180 plus 60 is 240. To do the radians, I think about how many are in each of the reference angle. So this is 7 times 30. 30 is pi over 6, 7 pi over 6. This is 5 times 45. So this is 5 pi over 4, because 45 degrees is pi over 4. And this is going to be 4 times 60. So this is 4 pi over 3, because 60 degrees is pi over 3. The hardest one of those might be the 45 degrees to get used to. So then I go back and I do my little colors. Let's zoom out. So first, I'm going to do my orange. So I'm going to do my 30 degrees. So it's going to have the same reference, the same point as 30 degrees. But now because I am in quadrant 3, they're both negative. So this is a negative radical 3 over 2 and a negative 1/2. Next, I'm going to do 45 degrees. So that's going to be 225. So it's going to be radical 2 over 2, radical 2 over 2, but they're both negative. Because we're in quadrant 3, x and y are both negative. And last but not least, I'm going to look at my 240 degrees, which has a reference angle of 60. So it's going to be 1/2 radical 3 over 2 with both of them negative. Negative 1/2, negative radical 3 over 2. Oh, that's a terrible 3. Let's try that one more time. Here we go. So if I wanted to find the cosine of 240 degrees, that would be negative 1/2. It's the cosine of 60, but negative because in quadrant 3. And one last quadrant, that's it. So the first one is going to have a reference angle of 30. The second one will have a reference angle of 45. And the last one will have a reference angle of 60. So now I'm going from 360, the positive x-axis, so I got to subtract. So the first one is 330. 360 minus 45 is 315. 360 minus 60 is 300 degrees. Okay, so 330 degrees is 11 times 30, so that's 11 pi over 6. 315 is 7 times 45. Again, that might take a little bit to remember, which is fine. And 300 is 5 times 60, so that's 5 pi over 3. Let's use our color coordination again. Oh, I'll start with green. So I'll do the 60 degrees first. So that's 1/2 radical 3 over 2. But in quadrant 4, only the y is negative. So it's a positive 1/2, a negative radical 3 over 2. Okay, next I'll do 45 degrees, which is radical 2 over 2, radical 2 over 2. But the y is going to be negative now, I'm sorry. The x is positive, y is negative. And last but not least is 330 degrees, which has a reference angle of 30 degrees. So it will be a positive radical 3 over 2 and a negative 1/2. So if we zoom out here, we can color coordinate this a little bit. So all the ones that have a reference angle of 30 degrees have the exact same points. The difference is, I shouldn't say exact, they have the same ratios, but they differ by positive or negative, but they both have an x of radical 3 over 2 and a y of 1/2. But depending on the quadrant, they could be positive or negative. Then all the ones that have a reference angle of 45s, all the angles right in the middle of every quadrant. 45, 135, 225, 315 are all going to be radical 2 over 2, radical 2 over 2, differing by plus or minus. They also, the radians will all have a denominator of 4 because they come from pi over 4. The orange ones will all have a denominator of 6 because they come from pi over 6. And the last one, the green ones, all have a reference angle of 60 degrees. Those are the angles 60, 120, 240, 300. They all have a ratio of 1/2, radical 3 over 2, or differing by plus and minus. And again, they will all, in radians, all have a denominator of 3 because they all come from pi over 3. So here is our final one. And of course, if we wanted to make it nice, you have the axis angles are always going to be at the edge here. And they kind of go alone because the axis angles are 4 separate axis angles. They do not have a reference angle.